Welcome to Brain Vision.
So in this problem, we're given that our function is f of x equals x squared, and we're asked to use a graphing function to determine the values of the derivative at 0, at 1, not 1, at 1/2, at 1, and at 2. All right, so let's look at our graph here for a minute. Here's the graph on our graphing calculator of f of x equals x squared, so y equals x squared. So the derivative is 0. Well, look, that 0 is a minimum point down here, and the derivative, which is the slope of the tangent line, is going to be horizontal here, isn't it? That's the only way you're going to draw a tangent line that doesn't intersect the graph anywhere else and become a secant line. So that's going to be 0 at 1/2. Okay, so let's blow this up a little bit. So at 1/2 here, at 1/2 I'm here, right? And that derivative there looks to be pretty much in parallel with y equals x, doesn't it? So that means it has a slope of 1. Okay, what about at 1? Well, let's see. Up here at 1 is here. That slope looks to be a fair amount steeper, doesn't it? Like maybe twice as steep. I think that slope's 2. Okay. What about up here at 2? Well, at 2, wow, gotta get way up here, don't I? For a little bit. That's here. That slope's a lot steeper, isn't it? That slope looks to me to be about 4. Okay. Then it says by symmetry, to estimate the value of f prime at negative 1/2, f prime at negative 1, and then f prime at negative 2. All right, by symmetry. Well, yep, you can see this graph is over here at negative 1/2, negative 1, negative 2, right? These are downward slopes equal to the upward slopes, right? Just negatives of them. So my symmetry, I'm going to say this is negative 1, negative 2, negative 4. Okay, then it says to guess a formula for the derivative. Well, what do I see? When x is 1/2, I get 1. When x is 1, I get 2. When x is 2, I get 4. It's like I'm multiplying everything by 2. So I'm going to guess this is 2x. Then it says to use the definition of derivative. Definition of derivative to determine the formula for the derivative. Well, definition of derivative says the derivative of f prime at x is the limit as h goes to 0 of f of x plus h minus f of x all over h. All right, well, let's begin to plug everything in. So this is x plus h. Oops. Got one most important part here. The limit as h goes to 0 of x plus h squared minus x squared all over h. So this is the limit as h goes to 0. X plus h quantity squared. Let's multiply that out. That's x squared plus 2xh plus h squared minus x squared over h. All right, well, I have x squared minus x squared, so that's gone. Everything that's left, I can cancel an h out of it, right? Out of each one of those terms that's left. Okay, so that means I have the limit is h goes to 0 of 2x plus h, don't I? That's all I have left. Well, h goes to 0, that term goes to 0. So that means I'm just left with 2x, as we had guessed. So there is the formula for the derivative of our f of x.